I've just hit my elbow off the desk. I've hit my funny bone just as I'm starting this video. This is about the 5th take, so I'm going to go for it this time regardless. I don't know why they call it a funny bone, because it's not funny, it's just painful. But anyway, greetings and salutations. While we are highly trained professionals dealing in complex mathematical procedure, we do encourage you to try this at home because it will hopefully enhance your mathematical understanding. So, this video is called Standard Form Explained, with a focus on IGCSE or GCSE style questions, and the learning objective is to be able to solve problems involving standard form. So, pictured is a giant 1 less than 3 math land sloth. At 6 meters tall and weighing around 50 tons, it has absolutely nothing to do with the questions. He is, however, handing out 1 less than 3 math flyers. Good on him. Standard form is a way of writing very big numbers in a simple way. Equally, we can write very small numbers, such as decimals, using standard form too. Land sloths didn't even know what numbers were, so just think how advanced we are in comparison to these helpful land sloths. So write the following in standard form. Part A, everyone likes a good part A, 4.6 million. Part B, 0.000387. Part C, we've got 2.3 times 10 to the power of 6 plus 4.1 times 10 to the power of 7. Part D, we've got 3 times 10 to the power of 4 multiplied by 4 times 10 to the power of 5. And finally, part E, everyone also likes a good part E, 4 times 10 to the power of 8 divided by 8 times 10 to the power of minus 2. So if you'd like to have a go at these standard form questions, please pause the video now. And I will then proceed to go through the solutions. So, 4.6 million. Now, we're going to write this in standard form, but first I'm going to write down what 4.6 million looks like. 4,600,000. Now, what we need to do is we're always writing standard form numbers. So it's numbers where we have the decimal point after the first significant figure multiplied by a power of 10. So they're always multiplied by a power of 10. So for example here, the first significant figure is 4. So we're going to write 4.6 times a power of 10. Let's look at how many places the decimal point has shifted. So the decimal point has shifted 6 places. And 10 to the power of 6 is actually a million. So 4.6 times a million would make sense. It's 4.6 times 10 to the power of 6. So basically we've put our decimal point after our first significant figure, and we've looked at how many places it's moved. It's 6 places, so therefore writing 4.6 million, 4,600,000 in standard form is 4.6 times 10 to the power of 6. So now we have a decimal, 0.000387. Now the first significant figure here is the 3. So we put our decimal point after the 3. So we have 3.87. It's always multiplied by a power of 10. But when it's a decimal, it's a negative power. So when it's a decimal, it's a negative power. And we can zero count. We're effectively looking at how many places the decimal point has moved. There's 4 zeros. Counting the decimal places, we would be going 1, 2, 3, 4. So we therefore write 10 to the power of minus 4. So that would be the solution there. Don't forget to write your equals sign. So 3.87 times 10 to the power of minus 4. And just to think about what 10 to the power of minus 4 would be, it would be 1 over 10 to the power of 4, and that would be 1 over 10,000. So 3.87 multiplied by 1 over 10,000, yeah, it's 0.000387. Okay, so moving on to part C, we need to add these two terms in standard form. So when we're adding or subtracting terms in standard form, we need to actually work out what they are. Now remember, we need to write the following in standard form. So once we have our answer, we need to convert it back to standard form. So 2.3 times 10 to the 6, just showing you what that equals. It's 2.3 times 10 to the 6. As I said earlier, 10 to the 6 is a million. So 2.3 times 1 million is 2,300,000. 4.1 times 10 to the 7. Well, this is going to be 10 millions because it's going to be 1 and 7 zeros rather than 1 and 6 zeros. So 4.1 times 10 million is 41 million. So now we can add these two numbers using the column method, and they add up to 43,300,000. And we finally need to put this back into standard form. So our decimal point goes after the first significant figure, which is the 4.33. It's moved 7 places, so it's 4.33 times by 10 to the power of 7. So, now moving on to part D. When we're multiplying numbers in standard form, remember that we can multiply numbers in any order. I always say 2 times 3 times 4, 2 times 3 is 6, times 4 is 24. But 4 times 2 times 3, 4 times 2 is 8, times 3 is 24. So you can always times numbers in any order you wish. So here, what I would do first is I would multiply the 3 and the 4, and that gives you 12. Then we can use our laws of powers. 10 to the power of 4 multiplied by 10 to the power of 5. We add the powers, so that becomes 10 to the power of 9. Now 12 isn't in standard form. That's going to be 1.2 multiplied by 10 to the power of 1. We remember our 10 to the power of 9, so we multiply them. So now we can multiply our powers of 10 again. It's going to be 1.2 multiplied by 10 to the power of 10. So just to recap there, we had 12 times 10 to the power of 9, but 12 isn't in standard form because the first significant figure is 1, so therefore it has to be 1.2, and that means we're moving the decimal point 1 place, so it's 1.2 times 10 to the power of 1, and we can multiply by 10 to the power of 9 and get 10 to the power of 10. 1.2 times 10 to the power of 10. Okay? So party, everyone likes a good party. When we're dividing numbers in standard form, I like to use the fraction line to show the divide. So we've got 4 times 10 to the 8 over 8 times 10 to the minus 2. Now 4 over 8, we can do this first. Similarly to how we did 3 times 4, we can do 4 divided by 8. 4 divided by 8 is a half. Simplified, 4 over 8 as a fraction is a half, and that's 0.5. So we've got 0.5. Now 10 to the 8 divided by 10 to the minus 2. When you're dividing indices, you're going to be subtracting. So it's going to be 8 minus 2, which becomes 8 plus 2, and that's why it's 10 to the power of 10. Now 0.5 is going to be a decimal version of standard form, so it's going to be a negative power. 0.5 is 5 times 10 to the minus 1 because there's 1 0. We're going to multiply that by 10 to the power of 10. So now we can collect our indices, and we have 5 times 10 to the power of 9 because minus 1 add 10 is 9, and that would be our solution. So I hope this has been a helpful tutorial on standard form. My elbow is now feeling better, so that's good news. It's Friday night, so have a great weekend, everybody. Hasta la pizza, arrivederci, so long, goodbye, au revoir, we'll see you next time. Ciao for now.